All right, let's do section 10.1, page 485, number 27, which reads, use the series and the function f of x that it represents from the indicated exercise to find a power series for f prime of x. And number 27 tells us to use exercise 21, which is the summation from n equals 0 to infinity of 2 to the n times x to the n. Or another way to write this would be n equals 0 to infinity of 2x to the n. And let's just write out a few terms here. The n equals 0 term is going to give us a 1 plus 2x plus 4x squared plus 8x cubed plus dot 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 plus 2 to the n x to the n plus dot dot dot. All right, now when you look at this, you should really see that this is a geometric series with a equal to 1 and r equal to 2x. And we know that the sum of this geometric series is going to be a, which is 1, over 1 minus r, which in this case is going to be 2x. Now, we always need to state the interval of convergence, especially for a geometric series. And we know that this sum is going to work as long as the absolute value of r is less than 1. So in this case, r is 2x, so it has to be 2x is less than 1. Or we can rewrite this as -1 is less than 2x is less than +1. And if I divide the whole thing through by 2, I'm going to get -1/2 is less than x is less than +1/2. And that's going to be my interval of convergence. So now I want to find the derivative, which means I'm going to want to take the derivative of both sides. And by that, I mean this side and this side. This is all going to be what I'm going to call f of x. So let's start by taking the derivative of the function part first. So I'm going to have f of x is going to be equal to 1 minus 2x to the -1, which is really just what this is, but in order to take my derivative a little easier, I'm going to make it a negative power. And that means that f prime of x is going to be equal to, I'm going to have a -1 here because I'm going to bring my power down. I'm going to have 1 minus 2x, and I decrease that power by 1, so I get -2. And then I have to take the derivative of what's inside, which is going to be a -2 because that's what's in front of the x. And so when I organize all of this, my negatives are going to cancel, and I'm going to have 2 over 1 minus 2x squared. So that's the function part. And of course, I also need to take the derivative of the geometric series part. So I'm just going to write an equal sign over here, and I'm going to take the derivative, like I said, of this side. So the derivative of 1 is going to be 0. And then for the second term, when I take the derivative of 2x, I'm going to get a 2. When I take the derivative of 4x squared, I'm going to get 8x. When I take the derivative of 8x cubed, I'm going to get plus 24x squared. And then I want to take the derivative of my general term up here, and my 2 to the n, I'm just going to leave the way it is. But then when I take the derivative of x to the n, I have to take this n power and bring it down, and I've got x to the n minus 1 because I need to decrease that power by 1, and then of course I would keep going for the rest of my terms. So I want to be able to write this in terms of a summation. So I have that f prime of x is going to be equal to my function, which is 2 over 1 minus 2x squared. And then if I want to write it as a summation, this general term over here really tells me everything. So it's going to be the summation from n equals 0 to infinity of 2 to the n times x to the n minus 1. And that's going to be my answer. Now, every time I have a series like this, I need to say the interval of convergence, but theorem 1 tells us that it's going to be the same as the original function, so it's going to be negative a half is less than x is less than positive a half.